Earth is doomed. A devastating force is coming, and we're running out of time. As civilization crumbles around us and our planet is destroyed, can we build spacecraft to take us to new, habitable worlds? Can humankind escape annihilation? Can we evacuate Earth?
It seems like science fiction. The end of the world, no going back, we have to escape, we have to evacuate Earth. But it's really impossible to say that it will never happen.
We have this view of stability on the planet Earth because it's existed for several billions of years and we've evolved on a reasonably stable environment.
We have small catastrophes all the time, like hurricanes, tornadoes, earthquakes, but in general, the human population continues to grow. This gives us perhaps a false impression about the future.
여보는 거 좋아하지?
아빠, 여기?
그래. 여기. 점수 한번 볼래? 잘 보이니?
All of human life, human civilization, and all the other life on this planet really exists in a tiny, precarious shell on this rocky object going around a star in the middle of a big and lonely galaxy.
Is that a shooting star?
Oh wow, yeah, look at that one.
The ups and downs that we've experienced as a species are nothing compared to what the universe can throw at us. Now, there's a whole list of bad things that can happen to a planet like the Earth.
¿Eso está pasando ahora?
Sí.
Vamos.
There are scenarios where our planet, the Earth, could be completely destroyed.
¡Abran el domo! ¡Abran el domo!
Get in the truck. Get in the truck. Get in the truck.
Reports out of cities from Tucson, Arizona to Okayama, Japan describe meteors the size of bowling balls raining down untold destruction.
Authorities estimate the death toll at 250,000 and rising. This could be the worst natural disaster the world has ever known.
Some leading scientists are now suggesting this deadly event may only be the tip of the iceberg, a signal that the destruction of our world is rapidly approaching.
If we were suddenly bombarded with a shower of large objects from space, that would be catastrophic for Earth, and it would mean many different things, but none of them are good.
Now, there are objects out in the universe that would make the Earth utterly uninhabitable or possibly destroy it forever. These objects could fling comets and asteroids towards us well before they actually reach anywhere close to where we are. So based on all of these unprecedented meteor showers, we would then turn our telescopes in that direction and look intensely to see what was there. We might begin to see, for example, a rogue object from somewhere else, from intergalactic space. One of the most extreme possibilities we can think of would involve an object that we call a neutron star.
A neutron star is a stellar corpse. A star much more massive than the Sun burns through its fuel extremely rapidly. And at the end of its life, when it runs out of fuel, the entire core of the star simply collapses.
This creates one type of supernova in a massive stellar explosion.
But what's left behind is this incredibly dense core made of neutrons. It's something like 10 kilometers across.
Because a neutron star is the mass of 2 or 3 suns, its gravitational pull is enormously strong. And that means that as objects get closer to it, they're subject to enormously powerful forces that can tear them apart.
The other really scary thing about a neutron star is that when it collapses on itself, it can shoot itself off into space at a very high velocity.
It can actually be sent hurtling through space at incredible speeds. So beware anything that gets in its path.
As the neutron star nears our solar system, its intense gravitational field will disturb the orbits of objects like asteroids, and some of that material may arrive as a deadly hail of meteorites right here.
What would happen next? The first thing that the scientists would do is to try to model potential scenarios for the path of this thing into our solar system.
If we determine that a neutron star was really headed in our direction, that's very bad news. You can't blow it up, you can't change its direction, you can get out of its way, or you can suffer the horrendous consequences of being destroyed by a neutron star.
Some scientists are calling it the end of the world.
It's called a neutron star, and astronomers think it's on a collision course with Earth.
If you're just joining us, we're talking with the University of Oklahoma astrophysicist Lawrence Kellogg. Dr. Kellogg, this whole scenario sounds like something out of a movie.
Yes, I suppose it does, but I assure you it's real.
Probably the first public response to a report that there was a doomsday device heading towards Earth is people would think, oh, well, Spielberg's making a new movie. This is probably some kind of gimmick he's doing to get everybody interested.
Where does this neutron star come from?
Some 60,000 years ago, a star at the edge of our galaxy collapsed in a huge explosion. We call it a supernova. Now, the violence of this event catapulted the dead remnants on a journey of thousands of years. Along its way, it is causing cataclysmic damage to anything it encounters.
One of the problems with our current age, which can be a good thing depending upon what the issue is or a bad thing, is that people are very cynical. We don't particularly believe what we see and hear. And you can imagine you'd have various people, various scientists get on the talk shows and say, no, this is really happening.
Do you mean the same thing could happen to us?
Yes, I believe it will. And just about every astronomer in the world believes it too. We have all read the same data.
So within a week or two, people will believe it. But the real question is, what will they do about it?
And when would this happen?
By our best calculations, 75 years. 75 years. The Earth will be destroyed. This is the end of Earth.
When people are faced with impending death, usually they go, one of two ways. They either bond together, right, in hopes of preserving humanity or at least preserving what is human, or they drop out and become hopeless. It would be incredibly important to create some kind of common goal. Some focal point that people could kind of bite into and own.
But if nature throws something at us that is so utterly catastrophic that the Earth would be utterly destroyed, that would compel us, I think, to try to go elsewhere. You might think we could go to Mars, or maybe some of the moons of Jupiter as a place to escape what happens to the Earth. But in this scenario, essentially nowhere is going to be safe. There would be nothing left for us here. This means that our only real option would be to look for another solar system, to get completely away from this destroyed, decaying wreck of a system that we used to call home.
How could we possibly do that? Can we really get 7 billion people off the Earth and take them to some other place where we could survive as a race?
It's a tremendously costly thing to do. It would take an enormous number of resources, people, and enterprise to do this. But if you're faced with certain doom, it might be the one thing that you want to do.
There's a neutron star headed toward our solar system, and every second the clock is ticking down to the destruction of everything we've ever known. In 75 years, the neutron star will arrive, and it will destroy the Earth completely.
It boggles the mind. Can we really rescue 7 billion people? You have to remember only about 600 people have ever gone into space in the entire history of the human race. Can we possibly move 7 billion people off of the Earth in a 75-year period? To be honest, I think we may have to face the likelihood that that won't be possible.
And then there's the problem of the distance that we're going to have to send them. We're probably going to have to go 6, 7, 8 light years at least, and that's 40 trillion miles.
One thing is pretty certain. We're not going to get there using the space vehicles that we have now.
The rockets that we know, Mercury, the Apollo, the Space Shuttle, these are all chemical rockets, and they're probably not going to do the trick.
It's just impossible to build a spacecraft to go to another star that uses chemical propellant. It's a cat chasing its tail kind of scenario, in that the more fuel that you put on to move the mass means you need yet more fuel to move the spacecraft. You just will never get there.
To make this work, we're going to have to build an absolutely colossal ship, and we're going to have to develop a new type of engine to propel it. The question is, can we?
We've got a lot to cover in a short time, so let's go ahead and get started. Here is E0302, the reason we're all here. It's a constant reminder that the clock is ticking. Today we'll be reviewing the initial proposals generated by our working groups in the Evacuation Vessel Division. I've been asked to remind everyone that this briefing, as well as this entire project, is classified.
Fortunately, nature gives us lots of ways to go to the stars, and most of these don't involve anything beyond known physics. But the engineering challenges are pretty tremendous.
Any plan to build a new space drive comes with great risks. But with the fate of humanity at stake, we're going to have to accept those risks, however great.
We've titled the project Horizon, and it represents the cutting edge in spacecraft propulsion technologies. We're going to be looking at a few approaches right now. Plasma. Promising, but it poses some real problems with regard to fuel and fuel storage, but this is a contender.
To make a rocket able to accelerate you to high speeds, the faster you can shoot the exhaust out, the better off you are. The idea of a plasma rocket is that we'll use electricity to accelerate our gas. And so then you can shoot things out to very large velocities.
But plasma, while it is more powerful, would probably require a lot of fuel. So really that puts us back to square one with the fuel problem.
Solar sails. This technology has the advantage of substantial research, especially in the last 15 years.
A solar sail derives its propulsion from sunlight. You can't feel it when you're out walking on a sunny day, but the light that's reflecting off of you is pushing on you.
There's a polymer fabric that we stretch over a wire frame. When the sail is in low orbit, it functions extremely effectively.
The solar intensity strikes the sail, and the momentum is transferred from the photons to the sail, propelling it along, much like the wind blows into a sail and pushes a ship.
And we've looked at designs of solar sails that, if they're large enough and lightweight enough, can get to very, very high speeds.
But the solar sail has an Achilles heel, and that is, it receives its acceleration by radiation pressure from the sunlight from the sun. And as you get farther away from the sun, that radiation pressure gets weaker. The sunlight gets weaker as you move away. It's kind of like driving on a long, lonely highway and there's no gas station suddenly for many, many miles.
There's another candidate for an interstellar drive, and this one seems to come straight out of science fiction.
Antimatter. Antimatter is the fondest hope of every propulsion engineer for the last 2 decades.
Antimatter is kind of the mirror image of matter.
It has the same mass as a normal particle, like a proton, an electron, but it has different charge and spin. And what is really interesting is if you bring a matter particle and an antiparticle together, as soon as they interact, they annihilate each other, and this releases enormous amounts of energy.
They basically come together and turn into pure energy, and that's the equivalent of Einstein's E equals mc squared. It's 100% efficient. And there's no comparison between the antimatter energy storage per pound compared with fossil fuels that we're very familiar with. It's tens of thousands, if not hundreds of thousands times more energetic.
But antimatter presents serious challenges. All that energy is really, really dangerous, and we don't necessarily know how to control it, much less funnel it through an engine.
It's extremely unstable, and in the event of engine failure, it's catastrophic.
When we make it, we have to store it in a vacuum chamber and contain it in some very strong magnetic fields so that it doesn't interact with the walls of the chamber. Because if it does, it's going to annihilate and produce energy. And just in layman's terms, it becomes a very, very large bomb.
This is, to put it mildly, a long shot.
So here we are. We can't use chemical rockets. Solar cells eventually will run out of thrust, and antimatter is too dangerous. So that's pretty bad news for a vessel that's designed to travel to distant stars.
Thank you all for coming. We're going to break now and get into our discussion groups.
But we might have an ace up our sleeves. There's a technology that might work very well. The irony is that this technology is not new. It's over 60 years old, and it might just hold the answer.
Today, whatever you do, wherever you may go, you are a part of atomic warfare.
So during the Manhattan Project in the 1940s, there was a physicist, Stanislaw Ulam, and he proposed launching a massive space vehicle that was propelled by nuclear bombs.
A number of scientists, including Freeman Dyson, took this concept to the next level, imagining a spacecraft that would be propelled by nuclear explosions. And they called it Project Orion.
Orion is really very simple in concept. Imagine that you have a very large spacecraft. And on the back of it, you put big plates with big shock absorbers.
And what you do is you take nuclear bombs and you eject them from the spacecraft, and they go some distance behind, perhaps tens or hundreds of meters. They explode, and the blast wave hits this pressure plate. And you set off multiple of these detonations, so it's bang, 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 and the thing gradually starts to move along and accelerates up to a high velocity.
The pressure waves propel the spacecraft and move it forward. Orion would get you going really, really fast.
In the 1960s, Freeman Dyson and Ted Taylor built a working model of this concept using conventional explosives to propel the model up into the atmosphere. This experiment was called Putt-Putt, and it proved that you could propel a vehicle using conventional explosives. The fastest man-made object now is the Voyager probe, which is going at 0.006 times the speed of light. At that speed, it'll take it tens of thousands of years to reach another star. But with Project Orion, we can go much faster.
Studies that have been done show that if you were to detonate a bomb behind it once every 3 seconds for 10 days, you would get up to a significant fraction of the speed of light. The reason that the research really stopped were the nuclear test ban treaties.
We shall not regret that we have made this clear national commitment to the cause of man's survival.
Which were a good thing. They basically stopped us from setting off nuclear bombs in the atmosphere.
Theoretically, we could just pick up the research that's been done on the Orion system from when it was being conducted in the 60s.
To conceive and build such a vessel is going to take cooperation on a scale never before seen in the world.
We would need all of the technological and scientific expertise that we have in the world.
We're talking about natural resources. We're talking about economies of the world having to give up the concept of money, working toward a common good.
The problem is we have a set deadline. There's no leeway in this. We have to have it done in 75 years.
I think if people were to be faced with some kind of real threat to their existence, you'd see a lot of different kinds of reactions.
News. People have been taking...
Now with the emphasis on social media, it's going to be a huge impact that's going to spread out in a millisecond.
I think that you would have people who would look to religious groups and religious organizations for answers. I think you'd also see quite an increase in rates of suicide.
The world is going to end. There's going to be massive chaos.
The clock is ticking down. We have 70 years or less to evacuate the Earth and avoid being destroyed by the neutron star. And what we've decided is that we're essentially going to build an escape vessel, a lifeboat for the human race.
Once you decide you're going to design and build a starship, the first thing you need is to assemble the best minds on the planet who can do the work.
People from all different scientific backgrounds, biologists, botanists, physiologists, physicists. The list goes on of people who it would be necessary to have their cooperation.
And allowing a central location where these men and women can interact and coordinate their efforts, I think will be critical to the success of this endeavor.
They're calling it the Horizon Project, and we've been granted exclusive access to show you this sprawling compound as it arises from the soil here in Florida. They've already dubbed this complex Starship City. In a few months, this site will be secured by the military, and the fight to save humankind will begin.
You bring the community to Starship City. You bring all of your scientists and engineers there. And then you start to do design work. They need to have homes to live in. And it's not just them, it's their families, because they have wives or husbands and children which might come with them. And it becomes a massive community which needs supporting.
And they basically will be living at Starship City, if you will, for the duration of the production of this vehicle.
And they might be there essentially for the rest of their lives, because this is a long-term project.
And this one upstart makeshift city is going to be the place where the entire future of the human race is to be determined.
Now, the first order of business at Starship City will be to figure out how to actually build the Orion and make it work.
Developing something like Orion is going to have several challenges. Well, the first thing you'll have to do is increase the production of plutonium. Because of the end of the Cold War, we haven't been building a lot more nuclear bombs, so we haven't been making it like we used to. And in fact, we don't make much of it at all these days. And so we'd have to do that. In addition to building up our supply of the plutonium fuel, you'd have to design the bomblets to be specifically used for Orion. You wouldn't be able to use decommissioned nuclear weapons from our arsenal, so you've got a whole new design effort for building these.
As you can see, the bomblets are going to be delivered to the pusher plate. One detonation every 3 seconds could get us to a respectable fraction of the speed of light, possibly even 7%.
So while we're perfecting the propulsion system, the next question will be, what exactly is it pushing? How big will it be? And what conditions will we need inside of it to prepare for the passengers?
One of the critical environmental elements that we're going to have to provide is one that we take for granted here on Earth, and that's gravity.
Gravity is an organizing principle for all large animals and plants, so we are structured in terms of our entire physiology and anatomy based on coping with gravity.
When you go into space, if you don't have gravity, one of the first things that starts to happen is that the bones in your body suffer calcium decay.
Your muscles start to atrophy. Other things happen to your physiology.
If you ever see guys that have come down from the International Space Station that have been in space for 3 months, when they get out of their capsule, they have to be supported. They literally will fall down. They're so weak.
Now we're talking about an entire lifetime spent in zero gravity. And so there's a whole host of problems. Number one will be the fact that I'm not sure if we can actually have men and women produce children in this environment. The reproductive system relies on gravity.
Every animal that has a bone system internally, that system would not evolve a proper way if it was done totally in a gravitational-free world. So if you were thinking about procreating in space, those offspring will have a difficult developmental time unless there's an artificial gravity that's created.
We don't even know what a body that grew in zero gravity from infancy or even from in the womb would look like. Would it operate like ours? Would it even be feasible to give birth in interstellar space? We have to assume that we will be raising at least several generations of humanity in space. And this is something that's never been done before.
Fortunately, there are fairly easy ways to simulate the effects of gravity, and one of those is through rotation.
Where you take the entire vehicle, slowly spin it around, and you create gravity through centrifugal force.
If you have a large cylinder that's slowly rotating, that force is pushing you to the outside edge of the cylinder. The centripetal acceleration to your body feels like gravity, and fortunately for us, that's good enough.
If a spinning cylinder is the way to go, then the question is, how big can we build it? Because that determines how many people we can fit inside. Well, the answer is pretty big. And this is where we can start talking about something called an O'Neill cylinder.
Gerard O'Neill is a professor of physics at Princeton University who postulated the design for a space colony where people would live on the inside surface of a rotating cylinder to produce artificial gravity.
This has all been simulated in computers, and we're fairly confident that this cylinder will maintain its pressure. In fact, over here we have the same type of pressure cylinder that O'Neill was theorizing would work in outer space. It's designed to hold an entire Earth's atmosphere worth of pressure inside of it. And we'd have pressurized ports here that we could open up and we could bring people and cargo in and out of the chamber. And then once it's sealed up, we know it's going to hold the amount of pressure we need.
Sounds good.
Light is another obvious issue. There's not much sunlight, even if you travel even just a few days away from the sun. So we're going to need some artificial lighting. But that's not as big of a problem as you might think.
We could run a rod down the center of the ship, which would be like the sun according to a daily cycle, because humans and plants and other animals rely on the cycles of day and night for their rhythms of life, for their survival.
These rhythms dictate heart rate. They dictate body temperature. So maintaining a 24-hour cycle is critical to human health.
The idea is that you could build very large, self-contained habitats in space, that you could put an ecosystem inside, and that you could have hundreds of thousands, perhaps, people living there in space in a self-sufficient, self-contained spacecraft environment. It's something that is on the scale of what you would need to launch to the stars that a propulsion system like Orion might be able to propel.
They're calling it the Ark. It will be a cylinder, 15 miles long and 2 miles across. It's roughly 4 times the size of Manhattan.
Scientists at Starship City say that the ship may hold up to 250,000 people, but no scientist or government official is answering the next question, and that is, who gets to go?
There's a death sentence for planet Earth, an inescapable date with destruction. Humanity mounts a desperate effort to escape the only home we've ever known. We must build a vast ship and fly it to the stars. We must evacuate Earth. There's a bitter pill to swallow here, and that is we're never going to be able to build a ship or a set of ships that can transport 7 billion people off the Earth, and we certainly won't be able to do it in time. If that's the plan that we try, we're going to fail.
Luckily for humanity, we don't need everybody to go. A small, genetically diverse group can multiply once they reach the destination. The question then is, how do we choose that small group?
Who gets to go, to me, is the big question. How do we select the people who get to go on this escape trip, if you will?
One of the first things that we would want to do is screen the DNA of as many people as possible. We would like to ideally collect this from all over the planet, from the entire population if it was feasible. What this would do is give us a snapshot of the human race at this point in time.
You're looking at essentially a founding group of people, human beings, on some distant planet. So the first thing you really want to consider is their survivability, which a genetic profile will at least give you a clue to.
Clearly, a key consideration is the biodiversity of the evacuees. We want to have a lot of genetic variability.
A population of people become very vulnerable when you have a monolithic genetic composition, very vulnerable to disease, very vulnerable to even sickness.
For example, if everybody was equally sensitive to an outburst of a flu or some kind of viral attack, then everybody potentially would die.
The scientific community would have to be directly involved in weeding out who is fit for this kind of project and also what kinds of people. The people that survive are going to have to be kind of biologically perfect in a way, as perfect as they could be, because we're talking about a survival over a long period of time.
One of the things that you really are looking for are people that have been relatively disease-free and have long life expectancies. You certainly don't want to have somebody on a spaceship who is diagnosed genetically as, for example, being a schizophrenic or somebody that is a danger to the rest of the population on the spaceship. You don't want to have people that are diabetics. You don't want to have people that have other kinds of long-term health problems.
What we're doing is we're reducing the gene pool of the entire human race down to just the passengers on this one ship. So it's very important that we save as much genetic diversity as possible and that the people be as healthy as possible.
In some places, you would need trained medical personnel to collect the samples and do the screening. But in other cases, people might be able to send in the materials themselves. We could create an evacuation eligibility kit and mail it to as many people as possible. It would be a simple kit with a pin or swab stick, an instruction card, and a return envelope. And they all get shipped back to Starship City.
Once they get back to the laboratory, these samples will be screened.
How does this work? We can sequence the entire genome of any human being now for just a few $1,000s, amazingly enough. We could say that somebody has a risk factor for certain cancers. We know there are certain cancer genes. We know there are certain blood disease genes. We could screen for these diseases very, very easily. And the more genetic information we have in the next few years, the more we can screen for this. You would want people that are relatively genetically predisposed to surviving under different environments. If I were to choose people with long-term survival skills, with minimum amounts of resources, I would take Inuits from Greenland or northern Canada because they've lived in very, very harsh environments for thousands of years. Those kinds of survival skills are very, very, very critical.
Genetics aren't the only criteria for getting into this group. There are certain skill sets that will be required. First of all, you need a crew to fly the ship and to maintain all of its various subsystems. Doctors, engineers, pilots, scientists, medical technicians, medical researchers, although we'll probably make those determinations further down the road.
No matter what criteria is selected, once you start deciding who gets to go, you're deciding who doesn't go. And that is a lot of people. In fact, it's 99% of the people who are not going to get to go. And no matter how objective you are in choosing your criteria, there's going to be many people who are going to see the selection process as being biased in favor of the powerful.
Wealthy elites would largely shape the priorities in this endeavor and would be involved very closely in selecting who would be the group of survivors that would actually make it into space.
We know that those in power are going to be writing the rules of who gets to go. They're going to have the brain power, they're going to have the financial expertise.
Protests have erupted in 71 different countries on 5 continents today. The protesters calling for the Starship program to be shut down. Why? Some say it's too much of an economic drain. Others say the selection of the evacuees is biased.
there are going to be lots of nations, lots of countries around the world with very few people selected to go on this journey.
There will be populations of people who are already resource poor who will want to be part of this project but won't be selected. And the struggle for resources is usually a violent one. There's a lot of room for tragedy.